Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Fidan binti Magasaki, and today I'd like to show to you how to use our software for plotting the control chart variable for R chart and text bar chart. So for an example, this is our question where we consider 5 random samples and this all the data. Record all the data. After that, we need to put the data into the Excel. For an example, this is my file. I put it on the Excel. After that, you need to open the URL. Firstly, you need to install the package. So search for QCC and then click create. As you can see down here, it's the QCC. So we can use the QCC package. After that, insert your data from the Excel. So import your data set and click from Excel. After that, you can see the data is already inside the R. So, I do this coding because you can also set the name of the data you want in here. So after you click X, the data is already saved. If you want to confirm it, you run this check. I name the data as object, so if you run, you can see the data is already filled down here. So your data is correct. After that, this is the coding for to find the mean. So the R will calculate the mean for you. As you can see here, it already calculate the mean. After that, run this coding to plot the control chart graph. You need to do this coding for the X bar. And as you can see, this is the plotting for the X bar. The data for the X bar is in control, but you need to know for the R chart before you estimate if the data is in control or out of control. So you run for the R chart. This is the coding for the R chart. So as you can see here, there is two data that is out of control. For example, the data for the 13 and the 19 is out of control. So we need to do a new control chart variable for this question. Okay. So for the new R chart, we need to plot the new graph. So firstly, you need to choose the data that you want. So for example, I delete the data for the 13 and 19 because the data is out of control. So I choose the in control of one and then you run. After that, this is data for find the mean and the upper control limit and the lower control limit will be different. So I insert the calculation for find the upper control limit and lower control limit. After that, if you run the graph here, you can see the control chart is already in control. So the X bar also do the same, delete the data, and if you run the chart, it will also in control chart. So the process is in control if you delete the data is not out of control. So thank you.
Okay, this is the first question. The thickness of the magnetic coating on audio tape is an important characteristic. Random sample of size 4 are selected and the thickness is measured using an optical instrument. The table below shows the mean X bar and standard deviation as for 20 samples. The specification are 38 plus minus 4.5 microns. If a coating thickness is less than the specification called for, that tab can be used for a different purpose by running it through another coating operation. Assume that the distribution of the thickness of the coating is following a normal distribution. Okay, this is a data that we given, and then there is a question. Plot the control chart for S chart and S bar chart. Okay, I'm using RStudio for solving this question. First of all, I'm install package QCC, and then after that I'm using this package. I type library QCC and put right here, and I'm type X bar and I put data X bar in this bracket 36.4, 35.8, 37.3, and then I want to calculate the mean for this X bar, so I type mean in the bracket X bar and then I put run here. Okay, after that I put the data SD in this question, this 4.6, 3.7, and I put here SD, C in bracket 4.6, 3.7, 4.2, 4.3. This is data for the SD, and then I tick run. And then I want to calculate this mean for SD, same like S bar. I tick run. So the answer for mean SD is 4.79. Mean for X bar is 37.175. So I want to know upper control limit for the X bar, and then I type UCL mean for X bar plus 1.628. This is the formula A4 because we have 4 samples. We use A3. We use A3 in because in this formula we use A3 because this is a formula from a statistic table. So we use plus 1.628 and times mean SD. This is the formula the formula to calculate upper control limit, and then I type here and then I tick run. So and then I call for the answer UCL, and then the answer will become out 4.97312. Okay, this is the upper control limit for the mean X bar, and then I want to know the lower control limit. So this is the formula, same like upper control limit, but it is minus 1.628. It is minus, and time mean XD. The formula is the same, but the difference is sign. The UCL we use plus, but LCL we use negative, minus. So we tick run, and then it will be come out like this. And we want to know the answer. We want to call it, so we use LCL again, and then we tick run. The answer will become out like this, and this is the answer 29.37688. Okay, and then we want to know the graph for this calculation. So we click run, and then it will become out this. This is the graph that we get from from that data. Center 37.175, this is the center, and this is upper control limit, and this is the lower control limit. Okay, there is no number beyond limits and no number violating runs. Okay, after that we want to know upper control limit for the for the S. So we type UCL as 2.266 times min SD. This is the formula from table statistic before is 2.266, and then we tick run. We will come out like this, and we call it again. And the answer is 10.85414. This is the upper control limit. And then we want to know the lower control limit for S. We use 0 times min SD, this formula. And then we tick run and we call it again. And the answer is 0. So we want to know the graph for SD. For SD in S bar, we type like this: QCC SD, type S bar dot 1, limits C, LCS, then UCL, and then we tick run, and the graph will come out like this. Okay, this is the graph for SD. This is the center, this is the upper control limit, and this is the lower control limit. Okay, this is the answer that we get from this calculation by using RStudio. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurdiana Shafir binti Jasin. I am the one that solved question number 1. As we can see from the question, 25 samples of size 50 are chosen from a plastic injection molding machine producing small containers. The number of non-conforming containers for each sample is shown in the table below. As the proportion non-conforming for each sample, we can see from the table there are sample, number of inspected item N, number of non-conforming item X, proportion non-conforming P are already given, and we need to construct the P chart. The number of non-conforming item X is also equal to NP. I construct the table again. Sample N, NPP, and P bar, and we calculate the upper control limit and lower control limit. P bar we can get 90 from the total sum of NP and the total sum of 1250. We get 0.072, and N bar equal to 50. We calculate the upper control limit using the formula given, and we will get 0.1x76, and lower control limit we will get negative 0.0377. So this is the P chart that we get. So there is one point that is beyond the upper control limit, which is the sample number 18. So we conclude that this P chart is not in statistical control. Therefore, we need to delete the sample number 18 and construct back the new P chart. On this, when we deleted the sample number 18, we will get total 24 sample, and the number of total N is 1200, while the NP is 80. So we get the new P bar, and we get P bar is 0.0667, while N bar is still the same, which is 50. And we calculate again the upper control limit. We get 0.1725, while the lower control limit, we get negative 0.0392. From that, we get a new P chart, and there is no point beyond the control limit, upper control limit and lower control limit, and there is no unwanted pattern. Therefore, the process is in statistical control. That's all from the question number 1. Thank you.
Assalamualaikum and hi everyone. I'm Ilana Nazar binti Mamaruzi. So I'm going to show you guys how I get the NP charts by using the R coding. Okay, first step, we need to install packages and then library QCC and then click run. This step is important to make sure that everything running smoothly when we run the codes. Okay, for the next step, we need to import our data. So click import datasets and then from Excel, then it will going to be like this. So click browse and choose our folder, and then our data will be here, and then click import. So we already insert our data to our R Studio. Okay, so next we need to insert our data into our R coding. So we need to run this code. So data and then our folder's name. So my name dissatisfied customer, so put it in here and then write it back in here and then click run. So and our data will be already into our R coding. Okay, next we need to run this code. So customers are known, so this 120 is our group sample and 8.5 is our mean, and this one is our standard deviation that we get from the calculator. So for the sample size, we have 300 because we know from the question we saw that 20 sample of size 300, so sample size is supposed to be 300, and the number of sample is customer over sample size, and sample is equal to wrap 1 ratio number of sample size and is equal to sample size, and data frame customers and sample. So we run all these codes, and then customer, we have the data frame, QCC groups, customer and sample, and then head customer and the customer unit equal to customers. So to construct the NP chart, we have the folder's number name, dissatisfied customers, and then our data, and then our sample size, and then our customer, and then this one is important, it's our type of charts, NP charts. So and then our summary, and then lastly click run. So then we have the summary here, and then we have the NP charts here. From the NP chart, we have the number of group 20, and we have the center is 9.2, and standard deviation we have the 2.98628, and then LCR we have the 0.24, and then UCL we have the 18.15. So this is our UCL and this is our LCL. So we have the one number beyond of limit, so this one is 1 point step beyond the limit, and number violating runs is 0, so we don't have any violating runs.
Assalamualaikum and hello. Okay, my question is number 3. Sample of fabric from a textile mill, each 100, are selected, and the number of equivalents of foreign metal are recorded. Data for 25 samples are shown in table below. So this question is construct a C chart for the number of non-conformities. Okay, and I'm use R Studio to solve this problem, and I install library package in this programming QCC, and I put one here, and then it will be come out like this. Okay, wait a minute. Okay, after that I put the data here. CC and C in bracket 5, 4, 7, 6, 8, 5, 6, 5, 16, 10, 9, 7, 8, 11, 9, 5, 7, 6, 10, 8, 9, 9, 7, 5, 7. And then I run. Okay, it will come out like this. And after that, I'm use OBS, QCC, CC type C, and why I put C because I want to out like this. Like this. We put right here. So be like this. And summary OBS, and the result is here. And this is the graph. Okay, this graph. We get the answer, number of group 25. And the center we get from this calculation is 7.56, and standard deviation is 2.749545, and LCL is 0, and upper CL is 15.80864, and number beyond limits is 1. This is a number beyond limits. Okay, this is LCL, and this is UCL, and this is LCL. The only number beyond limits is only 1. Okay, and this answer for this is all the answer of this question for question 3. Okay, that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Joanna Hida binti Muhammad Zaki. So today I'd like to explain the control check attribute for UCheck question number 4. So firstly, I insert the data inside the Excel for sample, and N is the amount expected. As we can see here, the number of sample is different for every number of non-conformatize. After that, I insert the data of CI. For the UI, we need to find each of the sample because the number of size is different for each number of non-conformatize. So the formula of U is CI divided by NI for each of the sample. So we get the answer here. After that, we just check the formula and we get the answer for each the UI. For the control chart, I use our software. So I already insert the data on the Excel. So I just import it into our software. So we just click here from the Excel, and then we just proceed. After that, you can see the data is already inside our software. So after that, if you run this UCheck, because I named the data by UCheck, if you run it, you can see the data below here. Okay, after that, to build a control chart attribute in R, we need to install the package first. Just click package and then you search QCC. If as you can see here, already appear quality control chart here. After that, you need to name the data, u.data, and just the data that you need to plot the control chart attribute. So for here, we need all the data, so I link the non-conformatize for every data here, 5 to 8. as we can see here. Am I correct? So 5 to 8. After that, because of the number of sample is different, so we need to also choose the data from 2 to 2. So we have 20 sample in different value. After that, to plot the control chart, we need to use this QCC the data type U. Type U is for U chart and the size is different, so we use n.data. After that, we run. Highlight the things that we want to run, so we click run. After that, we see the control chart here. As you can see here, the R software is already calculate for all the value, and the number of groups is 20, and the center is 4.68, and the standard deviation is 2.164, and the lower control limit and upper control limit also calculate by itself by the R. After that, it can also plot the data here. As we can see here, this graph show that the data is out of control, so we need to delete the data that is out of control. So I plot for the new chart that is in control chart, so I delete. As you can see here just now, that the data that is out of control is 7, so I delete data for the sample of 7, and delete for the U data and also NI data. After that, you just click the same way, click run. And now the control chart attribute for you is already in control. That's all.
Assalamualaikum. I am Nufara Hazira binti Ismail and I am going to explain about number 5. So, we have 20 random samples and each involving 10 customers, and we have serious non-conformities, major non-conformities and minor non-conformities, and we have classified them as C1, C2 and C3 respectively. So, the weights assigned is 50, 10 and 1. So we have to construct a control chart for the number of demerits per unit, or we can call it as U chart. First, after all the information and data have been keyed in, we have to find the demerits per unit for the sample, or we call it as U, where weight 1 times C1 plus weight 2 times C2 plus weight 3 plus C3. And we can get, for my Excel, we get C3 times M7 plus D3 times M8 plus E3 times M9 over 10. Next, calculating U bar, we get U bar 1 equals to 0.045, U bar 2 equals to 0.37, and U bar 3 equals to 0.57 by using the formula U bar equals to Ci over Ni. And then we have to find the center line of U chart or U bar by multiplying weight 1 with U bar 1, weight 2 with U bar 2, and weight 3 with U bar 3, and sum up all of them, so we get 6.52. The U bar represents the average number of non-conformities per unit in their respective classes. And then we have to calculate the estimated standard deviation of U, which is the square root of weight 1 squared U bar 1 plus weight 2 squared U bar 2 plus weight 3 squared U bar 3 over n. After that, we find the upper control limits and lower control limits, which we get 18.14 and negative 5.10 respectively. And then we take the U bar, lower control limit and upper control limit, drag them all the data, go to insert, choose chart, and then take the line chart, choose the 2D, and we will get what the graph that we want. So this is the graph that we get. The points are between the upper control limit and lower control limit, so it is said to be in control. Therefore, the product is within the specification.